Hi everyone, this video is on polynomial inequalities and this is going to be the second day of it, and we're going to take a look at it from a graphical perspective in addition to the algebraic perspective that we looked at. So it says right here, given the function f of x equals all of this stuff right here, so we know it's a quartic function, find all values of x such that f of x is greater than or equal to 0. And then it says use your knowledge of graphs and algebra to help you find the answer. So the first thing I want to look at is end behavior. So we know that this is an even degree. So we know that it's going to have end behavior that is going in the same direction. So it's either going to open up or it's going to open down. Because the leading coefficient is positive, it's going to open up. So our end behaviors here are going to give us some information. And we know that as x approaches positive and negative infinity, y is going to approach positive infinity. We know it's going to open up. So we know, like if I were to draw a graph of this, we know that it's going to open up this way and it's also going to open up this way. But I don't know exactly what it's going to look like quite yet. So we have our information for end behaviors. Now I'm going to take a look at my roots. I'm going to try to find the roots to help me out to visualize what's going on here. So I'm going to test some values. So I'm going to go just straight to the Desmos Scientific Calculator. I'm going to plug this in and I'm going to test values. Okay, so I've typed in the function right here, f of x, and now I'm going to test some values. So for starters, I'm just going to look at factors of the constant term. So the constant term is -9, so I'm going to look at factors of -9. So I'll try 1. 1 won't work, we don't get a remainder of 0, so I'll try -1. Doesn't work, I don't get a remainder of 0. I will try 3. 3 does work, I do get a remainder of 0. So let's go ahead and factor out that x minus 3. So I know that f of 3 is going to equal 0. So I'm going to take my coefficients for -35, -36, and -9. I'm going to do my synthetic division with x minus 3. I'll bring down the 4. 4 times 3 is 12. 4 plus 12 is 16. 16 times 3 is 48. -35 plus 48 is 13. 13 times 3 is 39. Add these together, I get 3. 3 times 3 is 9. I get a remainder of 0. So now, because I started off with x to the power of 4, I now have x to the power of 3. I need to do synthetic division one more time. So looking back at this right here, I can see that 3 works, so I'll try -3 now. So here, when I plug in -3, I get a remainder of 0. So now I'm going to do my synthetic division with -3. I don't need this remainder of 0 anymore. So here I've got -3, bring down the 4. 4 times -3 is -12. 16 minus 12 is 4. 4 times -3 is -12. Add those together, I get 1. 1 times -3 is -3, and then I get 0. So that tells me right here that f of x is going to equal, right here, this would give me a factor of x minus 3. This would give me a factor of x plus 3. And then this would give me right here, I have a remainder of 0 for 0 degree term, first degree term, second degree term. So this right here would turn into 4x squared plus 4x plus 1. So I'm going to go ahead and go through right here and factor this a little bit further. So this ends up becoming x minus 3 times x plus 3 times 2x with 2x. I know that they have to multiply together to give me 1, so I'll use 1 and 1, a plus and a plus. So that's what f of x is, but I'm going to rewrite this as x minus 3 times x plus 3 times 2x plus 1 quantity squared. So based on this, that means right here that my roots are going to be x equals 3, x equals -3, and x equals -1/2. So these right here are going to be my roots. But just a heads up, this is an order of 1. This is an order of 1 as well. But this one is an order of 2 because it is to the power of 2. So let's take a look at what this is going to look like in our graph. So let's just look at a rough sketch of our graph. So right here, we know that we have one root at -3. We also know that we have another root at +3. and we have another root at -1/2, okay? And then when I take a look at this right here, I can see that because it opens up, it's going to look like this. It's going to go through at -3. Because it has an order of 1, it's going to behave like a linear function at -3, so it's going to look like a line, okay? And then it's going to have some kind of a turning point. It's going to come back up to -1/2 because -1/2 has an order of 2. That means that it's going to behave like a quadratic at -2. So it's going to look like this. It's going to come back down. And again, I don't know exactly where the turning points are. This is just a super rough sketch. And then it's going to come back around. And then it's going to go to infinity in both directions. So we know it's going to look something like this. Well, if I'm looking for values where f of x is greater than or equal to 0, that means that we're looking for where it's going to be above the x-axis. So we're looking for where it's going to be above the x-axis right here. So looking at this right here, that means that everything all the way until I get to this root will work. And everything from this root on will also work because both of these, all of these values on the graph are above the x-axis. If you look right here, the remaining values right here are below the x-axis. But one issue that we have is that it can also work at -1/2 because this right here says greater than or equal to 0. So it can be equal to 0. So it would work there. So what does that mean my solution is going to be? Well, it would be everything from -infinity to -3, including that -3, and from 3 to infinity, including that 3, but also right here, x could also be -1/2. So what we'll say here is x is an element of -1/2 or -infinity to -3 inclusive, or 3 inclusive to infinity. That's one way that we could write our solution. We could also actually write our solution as -infinity to -3, close our bracket, and then from 1/2 to 1/2. So pretty much it's just at 1/2, and then again from 3 to infinity. Either one of these would work. Now let's just verify algebraically that this actually works. So if you remember, x equals 3 is one of our critical points. So I'll put 3 right here. Also have x equals -3 is another critical point. So I'll put -3 right here. And then we also have x equals -1/2 as our third critical point. So I will put that where it belongs right here. I'm going to go through this next piece pretty quickly because we've already discussed this and practiced it. So our first factor that we have here is x minus 3. Our next factor that we have here is x plus 3. And then the last factor that we're looking at here is 2x plus 1. I'm just going to cut down where all the critical values are. Okay, but I need to go back to this 2x plus 1 because we need to be really careful. This 2x plus 1 is 2x plus 1 squared. So we actually have to put squared right here, okay? Now, when I do this right here, x minus 3 is going to be negative all the way until I get to the critical point of 3. So at that point, it will turn into a positive, okay? X plus 3 will be negative all the way until I get to the critical point of -3. After that, it's going to be positive. Again, if you like to test numbers, you can just test numbers. That's totally fine. The next one, be really careful. 2x plus 1 squared is going to be positive everywhere except at -1/2. And at -1/2, it's just going to be equal to 0. But everywhere else, it's going to be positive because no matter what the number is, when you square it, you'll always get a positive value. So now if I were to do the total right here, that means that here we've got two negatives with a positive multiplied together. That's a positive. Two positives with a negative would be a negative. Same thing here would still be a negative, and then all three positives here would give us a positive. And because we're looking for where it's greater than or equal to 0, that means that for starters, because it can be equal to 0, since we can have equal 0 right here, we will have a closed circle on -3, -1/2, and at +3. If it was just greater than 0, then it would be open circles, okay? And we also know that it will work at all the places where it's positive. So it's positive here and positive here. So that means that this right here would be my solution. And just like we figured out before, we can say that x is an element of negative infinity to negative 3, also 3 to infinity, and also 1/2, negative 1/2. Okay? All right, in this next example, it says given the functions f of x equals this function right here and g of x equals this function right here, it says to determine all the values of x such that f of x is going to be less than g of x. Okay, so what I'm going to do here is I know that f of x is equal to this whole piece right here, so I'm just going to write that out. So I'm going to say 3x cubed plus 2x squared minus 6x plus 11, and that's going to be less than, and then here I know that g of x is 2x cubed plus 3x squared plus 11. Now I'm going to solve by getting everything all together on one side. So I'm going to subtract the 2x cubed right here from the 3x cubed and I get 1x cubed. I'm going to subtract the 3x squared from the 2x squared and I get negative x squared. I'm going to just copy down this minus 6x because nothing is like it, and then I'm going to subtract the 11 over, and that gives me nothing. So I get, I'm all done with the left side, the right side is just 0. Okay, great. So now we have lots of options for factoring, but usually I try to take out my GCF first, okay? And the GCF is x. Well, when I take out that GCF, now I have a quadratic that's easily factorable. So I'll use x and x, I'll use 3 and 2, I'll use a minus and a plus. Okay, so where are my critical points right here? So my critical points right here are at x equals 0, x equals 3, and at x equals negative 2. Well, when I go through and I look at this right here, so we know that our critical points are at 0, negative 2, and then positive 3. But because it can't be equal to 0, we are going to put open circles instead of closed circles on these values. So now I'm going to just cut down underneath each one of these. And I'm going to say that the values that I'm looking at are, and I'm going to say that the factors that I'm looking at are x, x minus 3, and x plus 2. Well, for x, it's going to be negative all the way until x equals 0. And then anything after that will become a positive. At x minus 3, our critical value is at 3, so everything up until this 3 will be negative, and then after that, it will become positive. And then this critical point right here, x equals negative 2, will be negative, positive, positive, positive. And now we're going to do our total. Okay, so right here, 3 negatives would turn into a negative. 2 negatives multiplied by a positive will give us a positive. Two positives with a negative will give us a negative, and then 3 positives multiplied together will give us a positive. But we're looking for where x is less than 0. So that would be here and here. So if I take a look at this, these are the spots that work. So that means that my solution is from negative infinity to negative 2 and then from 0 to 3. Nothing really new, but I just want to show you. So here are my two functions, f of x and g of x. It's really hard to see what's going on here. So I'm going to change my zoom a little bit. So I'm going to go from just like negative 5 to positive 5. And then I'm going to look at this from like negative 50 to maybe positive 50. I might adjust this afterwards. No, this is good so far. So if you notice, the red function is f of x, the blue function, is g of x, and we're looking for where f of x is less than g of x. So where's f of x underneath g of x? Well, we can see that f of x is underneath g of x until I get to negative 2. Until I get to x equals negative 2. Once that happens, if you notice, g of x now is underneath f of x. So as I follow along right here, from here, g of x is underneath f of x until they intersect with each other again. And then after that, we can see that f of x goes below g of x f of x goes below g of x until they look like they're about to intersect. So until they intersect, which is at 3. So that means that our solution is going to be everything within this shaded area right here. So everything but between negative infinity to negative 2. And then it picks up again. The red function is underneath the blue function again, starting at 0, all the way until 3. So in the green section and in this blue section, the red function, which is f of x, will always be underneath the blue function, which is g of x. After that, if you notice right here, the blue function is now underneath, okay? And that's it for this video. Let me know if you have any. Otherwise, I'll see you in class. Have a great one.